Introduction to Logic Analyzer. What is a logic analyzer? It is like a multi-channel digital oscilloscope that can analyze waveforms with more channels simultaneously. It decodes bus information, making it easier for users to work with. It captures and displays digital signals from the device under test using clock pulses. It's an instrument that shows the digital logic states and their timing relationships. It helps to understand the operational state of digital circuits. Features of the LAP-C Pro. The specifications of the LAP-C Pro include a maximum sampling rate of 2 GHz for 8 channels and up to 1 Gbit sampling points for 8 channels. It features long-duration recording with real-time signal transmission to a computer's hard drive for storage. Additionally, it includes 4 channels for signal generation, capable of simulating basic GPIO output to help trigger other circuits. It uses a USB 3.0 cable for power and data transmission. System requirements. The LAP-C Pro is a PC-based product with primary operations conducted on a computer, supporting Windows OS. It is recommended that the computer has a USB 3.0 port. The device features 2 sides for connections. The right side connects to the computer via a USB 3.0 cable for power supply and data transmission. The left side is used to connect measurement leads to signal and ground. The device also has a physical trigger button, allowing engineers to quickly generate signals from the device under test. For the measurement channels, we take 32 channels as an example, which will have A, B, C, and D ports. Each port has 8 channels, arranged in color as shown in the diagram. In addition to ground and external clock connections, this forms a rectangular shape of 2 by 5. Additionally, there are 4 channels for signal output, a fixed 3.3V power supply, trigger out, and trigger in at the bottom. Some usage recommendations. The sampling frequency needs to be set higher than that of the device under test. The software interface allows users to modify channel names and waveform colors. The save function can be used to store settings and measurement results. Users can also add and delete channels as needed. By default, all measurement channels are displayed. Users can delete measurement channels that are not connected to the device under test by selecting the option to delete signal lines in the signal channel settings. Alternatively, users can first click the option to delete all signal lines in the signal channel settings, then add measurement channels by selecting the option to add signal lines. User Interface A. All operations can be accessed from the main menu bar. B. The Quick Access toolbar provides convenient access to frequently used functions. C. The file bar consists of File Page, Memory Page, and Show All. The File Page displays the new added files. File Page can be minimized, restored, and closed. D. Facilitates quick reading of the samples and traces. E. See and edit channels. F. Set trigger conditions. G. Displays the captured signals as traces or as a numeric list. H. The control panel gives quick access to acquisition settings. I. Area where the navigator, packet list, statistics, memory view, LTR monitor are shown and find results. J. The action wheel provides shortcuts to functions related to acquisition and searching. Timer. During measurement, a progress window will appear. If a trigger condition is set, it will wait for the signal. Once the signal appears, recording will begin, followed by data transmission to the computer. Finally, if a decoder has been added, decoding calculations will be performed. User interface. Waveform unit switching function. Time display mode. When analyzing signals, it's often necessary to observe the time information of waveforms. You can use the time mode to calculate all the information based on time. User interface. Using the bars, function for analysis. The position bar helps to mark points. The T-bar represents the trigger bar, with time set to 0. Time on the left represents earlier moments, shown as negative values, and time on the right represents later moments, shown as positive values. Sampling setting. Sampling clock, internal sampling mode, timing mode. It is recommended to set the sampling frequency to 6 to 10 times that of the device under test. This increases the number of sampling points for each waveform, helping to reduce signal distortion. For Nyquist theorem, to avoid signal distortion, the frequency used for sampling must be more than twice the frequency of the original signal. The optimal sampling frequency should be 6 to 10 times that of the device under test. For LAP-CPRO logic analyzer, for UART and CAN buses, it is recommended to sample at a frequency at least 8 times the baud rate to ensure decoding accuracy. Trigger level setting. The trigger level setting is grouped by every 8 measurement channels. A 32-channel model has 4 trigger level groups. The trigger voltage level can be set between 6.0 and plus 6.0 volts. The input voltage tolerance for LAP-CPRO is plus 30 volts. When measuring a DUT, device under test, below 30 volts, the voltage level can be set to 6 volts. Principle of level setting. The reference voltage, VTH, is typically set as the average of the input signal's highest and lowest voltage levels. VTH affects the sampled duty cycle and glitches. The trigger level should be set at the midpoint between the high and low voltage levels. When the signal voltage exceeds the trigger level, it is interpreted as logic 1. When the signal voltage falls below the trigger level, it is interpreted as logic 0. Trigger function, level trigger, edge trigger. Only one measurement channel can be set to rising edge, falling edge, or either edge. If the trigger conditions of other measurement channels are set to edge triggering, they must maintain the same level for 2 consecutive clock samples to meet the level trigger condition. However, if the trigger conditions of other measurement channels are not set to rising edge, falling edge, or either edge, the signal of that channel will meet the trigger condition if it matches the set level for just 1 clock sample. By using the trigger level to determine whether a signal is logic 1 or logic 0, the transitions between 1 and 0 create edges in the waveform, which can be used as trigger conditions. Typically, at least one condition is set to trigger the signal during transmission. Trigger function. The trigger position affects the location of the trigger bar. Typically, the signal is measured using a recording method with the trigger position set to 10%. If specific conditions are triggered and there is a need to understand the signal preceding those conditions, the trigger position can be set to 90%. The trigger position percentage can be set between 0% and 100%, accepting only integer values. The trigger position determines the amount of signal captured before and after the trigger, depending on the user's needs. For example, if debugging an issue before the trigger, set the trigger position to 90%. If debugging after the trigger, set it to 10%. Users can drive specific I/O through the software to facilitate waveform recording, such as toggling a specific I/O after detecting an error state or toggling a specific I/O before performing a certain task. Search function. The search function allows the computer to find signals or packets for you. Click on Analysis. Search, select the channel and conditions, and the search results can jump directly to a specific number. To search for packets, set the data and values. Clicking will synchronize the waveform display.
This is the operation instruction for the search function.
Export function. Exporting allows data to be created in TXT or CSV formats. Typically, the packet list export is provided to others for understanding the data of the device under test.
This is the operation instruction for the export function.
Language and preference selection. Enter the preferences settings, which include 8 languages: simplified Chinese, traditional Chinese, English, Japanese, Korean, German, Dutch, and Portuguese. Software operation settings. Adjust the addition or removal of function buttons. Customize the colors of screen lines and background. Set the display information and width of channels. Configure shortcut keys. Set up automatic saving options.
This is the operation instruction for the language preference function.
Hardware setup and configuration.
This is the simulation signal board, which is connected to the computer. This is the power supply, and it can be switched to I2C, UART, or SPI mode. We will switch it to output mode. The current state is that it is outputting signals. Next, we will use the LAP C-Pro. Referring to the 10 colored channels mentioned in our handout, we will take out our signal wires corresponding to A0 and A1, matching them with the respective colors brown and red. We will connect the C-Pro interface to the pins on the testing cable, allowing the connection lines to connect to the A port, linking to the signals and ground. Now let's connect our cables to the simulation signal board. The small red board has 2 rows of pins. One row connects to the brown signal cable, while the outer row of pins connects to the black ground cable. The signals we are going to measure will then be transmitted to our LAP C-Pro device, waiting for the computer software to receive and process them. Next, we will take out the USB 3.0 power cable and connect it to the LAP C-Pro USB 3.0 interface. The other end, with the Type A connector, will be plugged into the PC. This completes the basic measurement setup. Isn't it simple?
Next, we will implement measurements and applications for I2C, UART, and SPI. We have prepared 3 commonly used buses by engineers, simulating I2C, UART, and SPI signals using a signal simulation board. We will share how to set their bus properties on the LAP C-Pro Logic Analyzer to successfully obtain decoding information. Download and installation.
Visit the Zero Plus official website. Go to the download page. Select a product and the model series. Choose Software Search. Click on Web, and the web browser will start downloading the file. Waiting for download. Once the download is complete, unzip the downloaded zip file. Run setup.exe to install the LAP C-Pro software. Select Application Setup. Choose Accept. Enter a name. Installation in progress. Installation complete.
I2C waveform capture and bus decoding.
After the installation is complete, open the Zero Plus software from the desktop. Next, begin the I2C configuration. Open the sampling settings. Set the sample rate to 50 MHz. Set the sample depth to 8 megabits. Set the trigger level to 1.65 volts. Set the A0 trigger condition to either edge. Click Capture to start signal acquisition. Use the mouse to select the area with waveforms and perform zoom out and zoom in. Click on the I2C decoder. The first channel is SDA. The second channel is SCL. Check the channel settings and acknowledge settings. The menu includes a packet list item. In waveform information, you can switch between time, sample, and frequency.
UART waveform capture and bus decoding.
Open the sampling settings. Set the sample rate to 50 MHz. Set the sample depth to 8 megabits. Set the trigger level to 1.65 volts. Set the A0 trigger condition to either edge. Start signal acquisition. Use the mouse to select the area with waveforms and perform zoom out and zoom in. This channel is for UART data. Click on the UART decoder. Check the channel settings and baud rate settings. The menu includes a packet list item and an option to switch the numeric type.
SPI waveform capture and bus decoding.
Open the sampling settings and capture the SPI signal. Set the sample rate to 50 MHz. Set the sample depth to 8 megabits. Set the trigger level to 1.65 volts. Set the A0 trigger condition to either edge. Start signal acquisition. Use the mouse to select the area with waveforms and perform zoom out and zoom in. Click on the SPI decoder and set the SPI bus parameters. The first channel is the clock. The second channel is the slave select. The third channel is MOSI. The fourth channel is MISO. Check the channel settings. Click OK to start the decoding process. After the decoding is complete, the waveform area will synchronously display at packet point 2. In waveform information, you can switch between time, sample, and frequency.
Thank you for watching.